Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. This is a viewer challenge, and it's an extension of a lot of videos I have here about the geometric mean. And there's one situation where you use the geometric mean, if you understand that, where you have a right triangle and you draw the altitude. So this is sent in by a viewer, and let's take a look at what the question says. So the question is, you have a right triangle and you only know one leg of the right triangle. Is it possible to find the other part of the hypotenuse? And I'm going to go ahead and add, can you find the altitude and the other leg of the large right triangle? So all you know is the leg and part of the hypotenuse. Is that possible? Yes, it is. Here's how you would do that. First of all, let's find out x, which is the other part of the hypotenuse. Now, if you remember in some of my other videos, there's two geometric mean theorems. One has to do with the altitude itself and the parts of the hypotenuse. The other is if you know one of the legs, that also serves as the geometric mean between the parts of the hypotenuse. And here it is. The leg 10 that I know from my diagram here is the geometric mean, so I'm going to put it in the lower left, upper right of this proportion. As long as they're diagonally across from each other, it could also be upper left, lower right. But I tend to put them in these two positions. So that 10 leg is the geometric mean between the near part, that's the 8 of the hypotenuse, and the entire thing. Okay, that's not x, that's x plus 8. All right, so here's how I write it. Again, it's the geometric mean between the near part 8 and the entire hypotenuse, x plus 8. Now we're going to cross multiply, which looks like this. Then here we're going to subtract 64 from each side. So 8x equals 36. We're going to divide both sides by 8. And the answer is going to be 4.5. All right, so that missing part of the hypotenuse is 4.5. That means, of course, the entire hypotenuse will be 12.5. Now, if I was going to extend this and say, what's the altitude here in red, or what is the other leg of the right triangle, I could use Pythagorean theorem. And I could also use the other geometric theorem. So let me go ahead and find the altitude using the other geometric theorem. So I'm going to label the altitude y, and let's solve for that. Now the altitude geometric theorem, geometric mean theorem, is that the altitude itself, that would be y, is the geometric mean between each separate part of the hypotenuse. So the 8 and the 4.5. All right, now when we cross multiply, that will give us y squared equals 36. And of course, taking the square root of each side is going to give me positive and negative 6. Now, we're talking about the measurements of a triangle, so we can't use a negative 6. The answer has got to be a positive 6. All right, so that would be the altitude, positive 6. Now, I know that the leg here is 10, the entire hypotenuse is 12.5, and I could use Pythagorean theorem to find the third side, this missing leg. I could also use Pythagorean theorem with this smaller triangle here. One leg is 6, the other leg is 4.5, and I can find that hypotenuse there of the smaller triangle. All right, well, thanks for watching this video. And I hope that I showed an application here of both of the geometric mean theorems. Thanks for watching. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard and take care.